So the constant rate of change, similar to yesterday with those unit rates, but today we're going to look at the rate at which something is changing. Okay, same idea as yesterday, just kind of a different name. So a rate of change is a rate that describes how one quantity changes in relation to another. So something is changing according to something else. Like the first one, the number of textbooks is increasing the more students we have. Because if we have more students, well, then we need more textbooks. Same thing with like days and money a lot of times, or the hours and money. The more you work, the more you get paid. The only thing that's different is we're going to look at tables and graphs today, but we're still doing the same thing. How many do we need for 1 unit? A constant rate of change, the word constant means same. So a constant rate of change is the rate of change of a linear relationship. So the same, it's changing by the same amount each time. So how we're going to do this, when we're given a table, the first column is your x value, which is which axis on your coordinate plane. Think about it.
Oh, that's the bottom one.
It's x, which one is that?
Bottom one.
The bottom or the horizontal one, right? And our y value is the second column. So what's your y value on a graph? The vertical one. So when we're finding rate of change, we're actually finding the change in y value on top of, like a ratio like we looked at yesterday, like a fraction, the change in x value. So just like you guys said, also if we look at a graph, that's going to be your vertical change. So how much point to point it changes vertically over the horizontal change. Also, I don't know if you guys know this, but the symbol for a triangle means change. So when I say we're going to do the change in x value, or finding the difference is really what we're doing, we're subtracting, over the change in the x value. If you ever see me put a triangle and a y, triangle and an x, that's what it's talking about. That's just the same thing. Okay?
How would you write that?
Okay, so how we're going to write it is I'm going to look and see what my change in each of those is. So my y values, 15 to 30, or 30 minus 15 is 15. That's my difference. 45 minus 30 is also 15. 60 minus 45 is also 15. So my y value is changing by 15 each time. So that's the number I'm going to put on top. And then I'm going to go look and see my x value. What are these changing by each time? 5. I'm just subtracting. 10 minus 5, 15 minus 10. So my change in x values is 5. So just like we did yesterday, when you got your ratio, then you wanted to reduce it down, make it smaller, or divide.
3 over 15?
3 over 1? Or just 3? Because 15 divided by 5. I know most of y'all can look at that table and see what the change is just by looking at it, or saying 15 divided by 5, 30 divided by 10. It's an easy one, and that's why we're starting with it this way. I'm showing you the long process because it's going to get more difficult. You will have decimal numbers, you will have bigger numbers, so we're starting with really easy so you kind of understand it better. So the graph represents the number of t-shirts sold at a band concert. Use the graph to determine the constant rate of change in number per hour. So we're doing the same thing. It's just now we have a graph. I'm going to find my change in y value, which is my vertical change, over my change in x value. And that's the horizontal change. So to do that, they gave me 2 points on this line. And I'm going to find the change in those 2 points. So it went from 25 to 30.
Goes up 5 each time.
So it went up 5. So my change in y, my rise, is 5. And then it went over 2 squares, but when I look at what those 2 squares represent, it went from 8 p.m. to 9 p.m. How many hours is that?
30. 1 hour, but it's 30 minutes. 30 hours.
It's just 1.
It's just 1 hour.
So each square is representing 30 minutes. I see what you're saying. So, but from 8 to 9, that's just 1 hour. So we're selling 5 t-shirts every hour. Okay, I'm going to leave that graph over there. So the next exercise down at the bottom, that table, we're doing the same thing. I want to find my change in y on top of my change in x and then simplify it. So I've got my x values, that's the side length. My y is the perimeter. So from 4 to 8 goes up 4. 8 to 12 plus 4, 12 to 16 plus 4. So that's my change in y. It's changing by 4 each time. So then your x values, yep, they're
Each box equals 1 hour.
that was scary. They're going up by 1 each time. Plus 1, plus 1. Hold on, I got a lot. So my change in y value is 4. It went up by 4 each time. And my x value went up by 1 each time. So my rate of change is just 4. We reduced that.
For me, the inside-out tables are a lot easier than the
So then on the graph, one more graph to look at. They gave us a point here that I'm going to look at and a point here. So I want to find the change in y over the change in x for those 2 points they gave us. So my vertical change, my rise, I went from 72 to 80. So what is that difference? 80 minus 72. 8. So that's my change in y. And then I went over 2 squares, but if I look at what my graph's going by,
Each square's an hour.
each square's an hour. So I went over from 10 a.m. to 12 p.m. So 2 hours, right?
This makes no sense.
But these ones are in the
On the graph?
This makes
The answer is 4.
Stop talking.
So look at your, yeah, like if you, from point to point, not the whole thing. I'm just looking at from point to point where I started, which was 72. And my point rose up, I rise, my vertical change went up to 80. So my change in y, 80 minus 72, is 8. That's why I put 8 here. Okay? Then I want to see from point to point, still same thing, point to point, how far I went horizontally on the x value. So I went over from 10 a.m. to 12 p.m. So that's a change of 2 hours. So that's where that 2 comes from. 4 miles in 1 hour, which is 4. Yeah, that's weird. But yeah, 4.